going to talk about defending the Scriptures again. That's our grand title of this study. In 1988, a fellow named Stephen Hawking wrote a book called A Brief History in Time. Here it is. A Brief History. It's a good science book, even though Hawking is an atheist. Now, he put together from the T equals 0, the instant of creation, all the way through up until modern times. What happened in the formation of the universe, how it formed, how the earth came about, and so on. So we're going to use, and it's good science. I mean, I've read this book. It's all based on Einstein's equations and Hubble's observations that we talked about a couple of weeks ago. It's the best science we have. Now, Hawking's problem is he wants to go beyond, on the other side of T equals 0 and tell us how something came from nothing, and he kind of gets real desperate when he gets over there. But anyway, we're going to compare Hawking's book to Moses' book, written 3,500 years ago by a sheep herder out in the Sinai Peninsula, just meandering around with 50 head of sheep, maybe, just thinking he's got the world by the tail. And then all of a sudden, he gets this message from God that he has to memorize, by the way. He didn't have any way to write this down. And so Moses eventually gave us this story of creation that we're going to talk about. And as I mentioned before, people say, oh, the Genesis story is not a science book. Well, you can make up your own mind about that. So here we go. We're going to talk about the astrophysical creation. And what I mean by that is this is the creation of the universe and the earth. Even though there's mention of life being created on and life does fall within the astrophysical creation, we're going to focus on the physics, the physical, astrophysical part of the creation. And then there's the biological part where animals and plants and things like that start showing up, and that'll be 2 weeks from now. So we're going to look at the first 4 creation days. And we're going to ask this question: how does proven science compare to the ancient words of Scripture? The closest thing we have is called the Masoretic Hebrew text, which conform very well to what we discovered in the Dead Sea Scrolls. But before I get going, I want to back up a little bit to something I talked about before, and that's translation and interpretation. Of course, the translation has to be correct, but the ancient Hebrew language only had a few words, 3,000 to 6,000 words, and so each word had multiple meanings. They were very general words. So in order to get the right meaning, the right interpretation, you had to establish the proper context. And sometimes that's a matter of opinion. If you don't have any facts to deal with, if you have no facts about the thing, you could establish a context that's just your opinion, not based on facts, not based on other circumstances. So that's what we're going to be trying to do, is establish a correct context, look at the translation, and then make our interpretation of what it says. Now, Hawking says that 13.78 billion years ago, a huge, not explosion, a huge release of energy occurred from a single spot. And I kind of like it. Most people think of the Big Bang, which is what we talked about a couple of weeks ago, as an explosion. Well, explosion is pretty chaotic and random, and it's hard to for an explosion. I mean, an explosion does follow the physical laws on the micro level, but this wasn't an explosion. It's like releasing a compressed gas. Now, at the instant of creation, everything was energy. Everything was energy. There was no matter I remember Einstein's equation, E equals mc squared. Matter and energy are interchangeable. It takes a little bit of matter to make a lot of energy, and it would, if you turn that backward, it'd take an awful lot of energy to make a little bit of matter, okay? That's just the mathematics of it. And so at this instant of creation, this huge amount of energy was released, and it was so hot that it can only be described in mathematical terms. Some people say, well, near infinite. Well, that doesn't mean anything to me. I mean, that's ridiculous. But it was way up there. It was a number that had a lot of zeros behind it. But it immediately started cooling, which is second law of thermo, I guess, but it's also just, it's a physical law. Started cooling. By the way, at the instant of this release of energy, the physical laws came into being. Now, we're going to talk about the physical laws next week. This whole thing was orchestrated and controlled by the physical laws, which I think, I said this before, my opinion is, the physical laws are the greatest single creation God has ever made. Because not only of the extent of their influence on the universe and earth, but the fact that they were there before the universe began. Proverbs 8 tells us that. The physical laws. I just read recently where there are 500,000 books in Harvard's science library that deal with what we're looking at up on the screen. 500,000 books. And Moses described this whole thing all the way to me and you in 894 words. So, if you gave Stephen Hawking's 894 words to describe what Moses described, I wonder what his version of it would look like, The universe, it comes into existence. There's a period called the inflation period, where the universe, early in its creation, 10 to the minus 36 seconds to be exact. I mean, the universe was the size of a half of an atom. That was real early. And it went through this colossal expansion to where in a millionth of a second, it expanded from the size of a half of an atom to 3 times the size of the Milky Way, 273,000 light years. Now that is faster than the speed of light, and I can see Ellen over there. Well, you can't violate the speed of light. Nothing material can go faster than the speed of light, but this was the universe. It can violate the speed of light itself. So anyway, as it cooled, the subatomic particles begin to form from this ball of energy. Then the atomic particles, the subatomic particles are the things that make up the atoms. Things like quarks and gluons and bosons and things like that we're not going to get into, but they're smaller pieces than atoms. And by the way, every one of them that exist right now were created at that instant. So I mentioned before, we're all the same age. All the subatomic particles in our body were created at this instant of creation. Now, the first atoms to form were hydrogen. After about 100 million years, the universe was hydrogen and about 23% helium and a 1% lithium. Just hydrogen, helium, lithium, the first 3 things on the periodic chart. So the universe was a big milky cloud of hydrogen. As a body gets bigger, its gravity gets greater. And so these hydrogen balls begin to form into balls, and they begin to get bigger and tighter and tighter and tighter, and then boom, they lit off basically and turned into stars, and it's nuclear fusion. 2 hydrogen atoms pushed together under great pressure and high temperatures will fuse and cause an atom of helium to form. Now, what do we know about nuclear fusion? What do you think, what powers the hydrogen bomb? Nuclear fusion. Atom bombs, fission. Hydrogen bombs, nuclear fusion. The sun is a big nuclear fusion reaction. Fortunately, now it's got so much fuel it's not exploding like a hydrogen bomb. Okay, so 100 million years, stars start popping all over from this dense hydrogen. Now these stars, like anything that burns fuel, they'll eventually run out of fuel. Our sun will run out of fuel. In about 5 or 6 billion years, it'll just, well, it's going to do what we've got up there. It's going to explode. As it burns down, the gravity gets less and less and less and less and less, and finally it just goes boom, it just blows apart. It's called a nova or a supernova in the case of a big star. A supernova. Now, when it does this, chemically, a lot of heavier compounds are created. So that's where all our heavy materials come from, the explosion of stars. Now, anybody know what those things are? You've seen them from the Hubble telescope, right? They're called nebula. Now, a nebula is the puff of stuff left over from an exploding star. If you took a bottle rocket and you lit it and it went up and it went pow, and you see a little paper flying and you see a little puff of smoke, right? That's what that is, except from a star blowing up. It's called a nebula. And the universe is full of those things. And if you see, NASA just released the biggest picture ever taken. It was of one of I think it was the Andromeda galaxy. And you can see these things just all in there. It looks like a dirty picture. Now, being a chemical engineer and knowing a little bit about spectroscopy, I can look up there and tell you I see copper, I see iron, I see a lot of different elements, sodium, in that nebula because of the colors. That green, that's copper. The red, that's iron. So you can look at one of these things and you can tell, literally you can tell what it's made out of. Now that thing is huge. You see the stars plucked in there amongst it? I mean, this thing is light years across. It's big. But that's how the heavier metals came about, from exploding stars. Now, how did the planets form? Well, this dust, if you can imagine a huge ball of dust, on that size, you're going to get a lot of static electricity, those particles rubbing together. And that static is going to cause this dust to start clumping up, knotting up. Does that make sense? And you get these big balls of dust. And then the other thing that happens in a static situation like that is you get what's called a static discharge, which is, what's another name for it? Lightning, okay? 50,000 degrees is how hot a lightning bolt is. Hotter than that, actually. So this lightning's popping through all these dust balls, and when these dust balls that are near this lightning, this quote, this static discharge will stay sciencey. What do? They melt. They melt and they make little bitty pellets. And then this goes on for years and years and years and years. And then all of a sudden you've got some nice sized big rocks forming, and then bigger rocks, and then rocks are running into rocks. And the next thing you know, you've got a rock that's big enough to start exerting gravity. Now, when you get a rock like that, things change. You get a rock 100 miles across, and that thing is starting to pull in stuff from its gravity. little stones that are floating around out there, just like our Earth does. When we go through a little field of tiny rocks in the Earth, they come in, we see them, we call them meteor showers. So that's how a planet is formed. That's what it looks like. And once it gets big enough, like this one, it's just vacuuming up all of the garbage out there in space left over from that nebula we talked about. Are y'all following me? So the planet grows and grows. As long as there's garbage in the air, the planet's going to grow. And there's a lot of garbage in the air. Now, about 4.9 billion years ago, according to science, a star in one of the spiral arms of the Milky Way galaxy ignited. A medium-sized star. Scientists have found that huge stars doesn't do well with planets. They usually eat them up or burn them up. But a medium-sized star is perfect to capture a planet. And so here's a rock floating around, or a lot of rocks floating around. All of a sudden this star comes into existence and starts capturing. Some of the stuff goes into the star, but a lot of it starts to orbit the star. And they colliding and banging on each other all the time. So that's how Earth and Sun met up. And so the Earth picks this orbit. By the way, almost a circular orbit, which is extremely rare in the universe. I don't know if they've found another planet with a perfectly circular orbit. But that's one of the things that's required for life to be possible, a circular orbit. So the temperature, we don't get closer and farther away from the sun every circuit, every year, like Mercury does. Mercury gets close to the sun and then it gets away from the sun. So these vast temperature changes. So we call that a protoplanet. It's like the early Earth was. Now something like that was caught by the sun. And now, anybody old enough in here to remember Mount St. Helens? Good. This is a picture from Spokane, Washington. And some of you guys remember this. I mean, this is in the middle of the day. The sun was completely blacked out for many days, and that's what it looked like on the surface of the Earth. Because all these meteors hitting and all this burning and I just read a brand new paper on that just recently, and the scientists confirmed this, that these things were kicking up so much dust and debris in the atmosphere that there was and the Earth's gravity was such that it would hold it, that it had this thick band of debris. And that's what it must have looked like. Of course, there weren't any cars on the Earth 4.3 billion years ago. Along comes THEA, T-H-E-A. That's what the scientists call it. Apparently, in the same general orbit of the early Earth was another big rock, a fifth the size of Mars. That's a pretty big rock, a fifth the size of the Earth. And guess what? They were heading down the same road. There's an excellent video on YouTube showing this. In fact, that's a clip from it. This thing comes in and wham, hits the Earth. A glancing blow. Now, if it had hit the Earth center line to center line, both THEA, the little one, and Earth, the big one, would have been obliterated. They just made some new rocks. But THEA hits the Earth a glancing blow. So what do you think that would cause the Earth to do? You hit it. Oh, Janet's got it. It started rotating. Right? That happened 4.25 billion years ago. And not only did it, when it hit the Earth, it completely changed it. First of all, it blew away all that smoke and dust and stuff that we saw in the previous slide. And the second thing it did was the piece of Tia that was left over from this collision, the Earth's gravitation captured it and it became our moon. So this in one fell swoop, we lost that horrible, toxic, smoky, dusty, dark atmosphere, and we gained the moon. Of course, it took a little while for all this to settle down, but once it settled down, we had an Earth and we had a moon. And the Earth, some light could actually come through this atmosphere, even though it still looked like a cloudy day. It was still dusty and full of water vapor, a lot of water vapor. The Earth was bombarded by a lot of comets. Comets are nothing but big dirty snowballs. They're big blocks of ice. Has anybody ever heard of Tia? Did you know that that's how the moon formed? And you know how we found all that out? We sent some guys up to the moon. Y'all remember that? They brought home some rocks. Guess what? They're the same age as the Earth. Now there's some stuff in the moon that are completely different from the Earth. Not found anywhere in the Earth because Tia was no telling what it was made out of, but there's obviously a big chunk of Tia made up the moon, but it also grabbed a lot of the stuff that was on the surface of our Earth, as you can imagine. Anyway, it blew all this stuff out into the atmosphere. All right. The next thing happens after Tia and the moon are formed, the Earth cools down, starts to cool down. All of this bombardment of meteorites slacks off some. And the Earth, all this water vapor that's in the canopy, the atmosphere, starts to condense and starts to fall, and next thing you know, the Earth is covered in a shallow sea. Not a deep ocean, but a shallow sea. And then as it cools a little more, the more and more of this ocean, it just rains it out of the clouds. And then all of a sudden, that starts happening. But between the volcanic action and the tectonic action, the plates of the Earth colliding and pushing land up. As the Earth began to shrink a little bit, cooling off, land appeared. Now, scientists say there was one big ocean and one big continent. And the scientists call that continent Columbia. They named the space shuttle after it. Columbia was the first land on the face of the Earth. One big giant. Now Columbia split apart, came back together, went different ways as the tectonic plates moved. You can find rocks in Spain, and you can find the same rocks in Rio de Janeiro, because the way these, things were put together and they came apart. And actually, the United States and Europe are coming together again about the rate of the growth of your fingernails. So in a few 100 million years, we'll be looking at the coast of Europe, if y'all can hang on that long. About 3.8 billion years ago, something significant. Now, 3.8 billion years ago. This was about 4 billion years ago. Something interesting happens. Prokaryote cell. Anybody know what a prokaryote is? You got it? All right, I'll have to tell. There are two kinds of cells in living plants and animals. Only two. A prokaryote, which is a single cell animal only. That's it. When they reproduce, they make another cell and that's it. You see a little bit of DNA swiggling around in there. We're going to talk about that in a couple of weeks. That's the first living thing on planet Earth. There's a lot of talk about how that rascal got here. The naturalists, the atheists, they have no answer. Even Richard Dawkins said, we simply don't know. But that's the first one. Now later on came the eukaryotic cell. See, you just couldn't get it out, okay. And a eukaryotic cell is a cell very similar to that, except it has a nucleus where the DNA resides, and it can be more than one cell. We have eukaryotic cells in our body. They're all built the same. But there were, at that time, there were no eukaryotic cells when the first life came along. They came along about 1 billion years later because they were different guys. They had some different things that they could do that this one couldn't do. Now, you can probably imagine that the way the earth was formed, I know the Kimmies, Sam and Alan can imagine it, all this water and all this dirt and stuff, the water had to be just horrible. It had to be poison, and it was. It's full of selenium, arsenic, iron, aluminum, boron, all kinds of stuff mixed in, dissolved in this water. I mean, if you'd taken a drink of the water when this little guy came along, you wouldn't live long, it'd kill you. But that guy, he loved it, okay? What the prokaryotes started doing is they started metabolizing. They were eating this stuff up, billions and trillions. By the way, you ever heard of staph, E. coli, strep? Have you ever heard of those? It's our friend prokaryote. They actually left fossils for us. This is that they call stromatolites. These are in Australia. And they're like coral, but they're left over from these little animals as they died. But anyway, these prokaryotes feasted on this poisonous water in the oceans. And for years, hundreds and hundreds of millions of years, they just were cleaning it up. So these prokaryotes were hugely necessary for creating an environment that humans could eventually live in. The early Earth's atmosphere was, you think we got greenhouse gases now? I mean, the Earth was 50% carbon dioxide. I don't know if that number's right, but more than a few parts per million that our government wrings their hands about. These eukaryotic ants converted carbon dioxide into oxygen. Now, why didn't they convert it into something else? They converted it into oxygen and sugar. Oxygen and sugar. What does a human being need to survive? Oxygen and sugar. Now, my wife Janet would say, not Hershey bars. Now, that's not what we're talking about. We're talking about glucose, okay? Now, here's these little beasts out there making oxygen for us. The other ones are cleaning up the oceans. I mean, that's astounding to me, you know, the way that works. Okay. 1 billion years ago, and science believes it's between 700 million and 1 billion. I tend to go to the 700 million. Blue sky appeared for the first time. You could see the sun. You could see the moon. All of this cleaning up of the atmosphere by those guys that were converting everything to oxygen. A blue sky appears. By the way, by this time, when we get to blue sky, then we can have more complex plant life come along. We had fresh water. We had land with fresh water on it. So the earth is just full of plant life. And I say complex plant life, I'm talking about plants that have roots and stems and leaves. These prokaryotes, they were just like little bacteria, and algae is what was literally the first plant life on earth was algae. So, that's what Stephen Hawking said. And I think he's right. I've read a lot more books than Stephen Hawking ever wrote. I mean, he wrote A Brief History of Time, and then he wrote An Even Briefer History of Time. I guess he must have thought we didn't get it on the first time around. And then his most recent one is called The Grand Design. He's an atheist, okay? But he's a reasonably good scientist, okay. Now, The big question, what does Scripture say about all this? Can Scripture possibly duplicate that story I just told you? Well, you know, Scripture's not a science book, is it? Well, let's see about that. Genesis 1:1. Now, we've pretty much wrung this one out last couple of weeks ago. In the beginning, God created the heavens and the earth. And yet, this shepherd living in the deserts of the Sinai Peninsula wrote it down, or didn't write it down, but was telling it to his people 3,500 years ago. Now, Einstein and Lemaitre and Hubble and Penzias and Wilson and those guys get credit for it, right? Called the Big Bang. Now, the universe had a beginning, which current scientists call the expanding universe cosmology model a Big Bang. And no conflict there. So I guess it's one for Moses, one for Hawking, except Moses figured it out 3,500 years ago. Now, let's talk a little bit about the Hebrew words. Bara is the Hebrew word for create. And it means, generally speaking, the word create means something from nothing. There's several words used in the Bible about making things. Okay. Anytime you see create, we're talking about something that there was nothing and now there is something, which we've never seen happen in any laboratory. There's no, it's pure conjecture if that could ever happen in a physical world. There's another word, asa, which is made. It's not in this verse, and it means to put something together with, you know, like we make a dog house or something. We get some boards and some sheet metal and whatever, and we nail it all together, and we made something. So there was material ahead of time, and now we've made something different. And we'll see those two words as time goes on. Create, though, means make something from nothing. So he created the universe, and then it says kind of and the earth, but later on he kind of clarifies it and says that the earth was made, it was not created. Now, let me give you a little bit of perspective. I kind of jumped ahead of myself. Where is the writer? Of course, there was no writer for 13.78 billion years ago when science says this was done. But anytime you write a story describing an event, you're somewhere, right? You know, you've got to determine, I'm going to be right here when I describe this audience. If you were watching a tornado from an interstate overpass 7 or 8 miles away, you could see what was going on. Now, let's say you were in the farmhouse that tornado hit, and the two guys, the one on the interstate and the one in the farmhouse, got together and wrote down what they saw. You think it'd be the same? It'd be completely different based on where they were with respect to what was going on. The perspective of the observer, let's call him the observer, was on the earth. He was looking at because if he had been on the earth in one verse and out in the universe in another verse, this thing wouldn't make any sense at all, would it? I mean, you can't change around with every sentence and have a story that is anything but gibberish. So we're going to think about Moses, or the observer, not Moses, but someone standing on the surface of the earth, so that's how this thing is described. And the verse 1 I call the executive summary. It just, it doesn't tell us how any of this stuff happened. Moses got it right 3,500 years ago. Now let's look at Genesis 1:2. And the earth was without form and void, and darkness was upon the face of the deep, and the Spirit of God moved upon the face of the waters. All right, the earth was without form and void. You remember back my protoplanet? Remember what Stephen Hawking said? The earth was continually changing. Every day it was different. It didn't even get round until it was 500 miles across. Every day the earth was different. It was void. It didn't have any life or anything that you could point a finger to and say there's a this or that. I mean, it just was a continually changing, void, dark place. Darkness was on the face of the deep. Now, the latest science says that early in the Earth's formation, there was some water on the Earth. Now, it got all blown away when we get to verse 4. But if you look at Job, for instance, one thing I like to do is, Genesis is a creation story, but there's a lot of other creation verses in the Bible. And you look over at Job, at first he chides Job in chapter 4. Where were you when I laid the foundations of the earth? Now, Job was talking about, I've been done wrong and all that. And God says, well, I'm your helper, and look, I can handle this. Where were you when the foundations of the earth were laid? Now, over in, and he goes on a little bit, and then he says, when I made the clouds its garment, the earth's garment, and thick darkness its swaddling band. God is describing the early earth when it was set on its foundation, its warped space fabric, okay? We didn't think the earth actually had a foundation until recently. It does. It's sitting in an Einstein's space-time fabric. He says, I made the clouds its covering and thick darkness its swaddling band. So he's describing the earth right here in Genesis chapter 1, verse 2. It's just a reference, okay, a connection. Science says the early earth was a chaotic ball of space debris held together by strong gravitational forces. It was not anything like the earth today. The earth was dark because the dust and debris completely blocked out the sun's light. Now, not only does Genesis say that, but God again repeats it over in Job. There's a word in there, it says, and the Spirit of God moved upon the face of the waters. There's the word Ma'im. It's the root word for Shamayim, which is the word for the heavens. And the word picture here is a vast, fierce, unknown place. It's like if you stand on the edge of the ocean, which was a terrible thing for a person to do in 3,500 years ago. They were afraid of what was beyond the horizon, what was under it. I mean, they just had a horrible fear of it. So that's why this word Ma'im was translated as waters. If you've ever been on the ocean at night, being out on the ocean at night, on a dark night, is a scary thing. I could tell you a story about that, but we're out of time. We're not going to have the time. But Ma'im, dark, fierce, unknown, just scary as all get out. Translated waters, because that's a good translation. But that, as far as an interpretation goes, that's kind of what was going on in these people, in the minds. This earth was just a scary place at this point in time. Genesis 1, 3 through 4, and God said, let there be light, and there was light, and God saw the light, and that it was good, and God divided the light from the darkness. Now this little verse, most people read it and don't think a second thought about it. But this tells us about Tia. You remember Tia? There was darkness. Even Job said the earth was covered with a swaddling band of deep darkness. Boom, here comes the Tia, knocks all that away. And guess what? There was light. This observer on the earth could actually see some light. Now he couldn't see the sun, or he couldn't see the stars that were created in verse 1. But he could see light for the first time on the earth. This collision with Tia. And the reason I know that that's what he's talking about, because he says, and God called the light day, and the darkness he called what? Night. You remember I told you the earth started to spin when got hit by Tia? Well, here's a description of day and night. You don't have day and night unless you have a spinning earth, right? Am I right? Can any of you think of day and night not a spinning Earth? All right, this Earth was spinning, and at this point we don't know how fast. It might have been much faster than it is now. I don't know. Not many people. There's some, theories about it. This is the first use of the Hebrew, the little three-letter word yom. Now, before you guys get out of here, y'all will be yom experts. This little Hebrew word means, it's a general word for time. It's used lots of times in the Bible, 2,000 or 3,000 times in the old scriptures. And it means, generally speaking, it means day, or in some cases, 12-hour day, like the first time it's ever used. It says, and God called the light day. Now, when you look at the context, you have to interpret that as a 12-hour day, right? You had day, you had night. Day was a period of daylight, yom, 12-hour day, right? Then later on, he says, in the evening and the morning were the first day. Now, that's a different length of time. Could be 24 hours, could be a lot longer. When you read Isaiah, he uses the word day to mean periods of time. For instance, he would make a statement like, in the day of our Lord, or in the day of vengeance, or in that day such and such will happen. And he's talking about periods of judgment. For all you Isaiah scholars, you know what I'm talking about. He uses the phrase, in that day, 40 times. So he's using the word yom, and that's the word yom, day. He's using it to mean periods of time. And that's a possible meaning. It could mean there was evening, there was morning, and then there was a period of time. That was the first period of time. That makes sense? Now, some people might say, well, what about evening and morning? That's not 13 billion years. Well, evening and morning could be a metaphor. There's a lot of metaphor in the Bible, and the Bible is simply loaded with it. That's one of the reasons it's kind of hard to really understand it as quickly as, Jesus said, I am the door. Well, he wasn't a door, was he? He was, he was the passageway to God, but he was not a physical door. That's a metaphor. Okay. Got to move on. We're going to talk about the word yom. How long was a creation day in a couple of weeks, and we're going to do a whole study on it. And when we get through, you should be able to make up your mind how long a creation day was. It all depends on the interpretation. And the interpretation depends on the what? Context. Okay. The circumstances or the facts associated with it. And God said, let there be a firmament. Let there be a firmament in the midst of the waters. And let it divide the waters from the waters. And God made the firmament and divided the waters which were under the firmament from the waters which were above the firmament. Well, y'all have read that 1,000 times, probably never thought a single thing about it, but that is a very, very scientific statement. What is being described here is called the water cycle. Now, I kind of missed it in my Hawking's presentation a minute ago, but I didn't really. The clouds got up, they cooled, the rain fell and filled the land with water. A water cycle is where the heat from the earth evaporates the water. The water gets up in the clouds, it's cool up there. It condenses and falls back down to the earth. Right? Every one of us in this room is familiar with a water cycle. So how many planets in the universe have a water cycle? Anybody want to take a guess? David? Only one. This one right here. One planet in the entire universe has a water cycle. That's because of the infinitesimal small temperature range we have on Earth. Well, it's not infinitesimally small to us. It's 100 degrees, basically. From the boiling point of water to the freezing point of water. So we have water vapor, and we have ice. People say, oh, well, that's not right. So if anybody ever challenges you on the fact that it's the only one in the universe, Just ask them to give you the scientific paper on one they've discovered in the universe like this. They can't do it. Now they'll say, well, there's billions and billions and billions of planets out there, and there probably are. But so far they've not come close to finding anything. That's why they're so anxious to find water on Mars. You ever wondered why anytime we send something out into space, we're looking for water, got to find water. Oh, here's ice. Well, you know, ice that don't count. You got to have liquid water. So, David's right. We're the only one in the universe. And I want you to say that to people. And it's because of this water cycle that's mentioned in Genesis 1, 6, and 7. The word rakia means expanse. We call that the atmosphere, okay? From the surface of the earth, there's an expanse up to the clouds. Now, technically it's called the troposphere. It's only 5 or 6 miles up. No, it's 11 miles up. It's only 5 or 6 miles thick, and it holds all the water that's not liquid or ice on the earth. There's a lot of it. So far, we're kind of clicking right along, right? I mean, you know, 500,000 books in the Harvard Library and 894 words in Moses. So he's mentioned Tia, he's mentioned the beginning of the universe, he's mentioned the water cycle, he's mentioned light first getting on he's mentioned the fact that it was covered in darkness. He's doing all right. All right, let's see what's next. And God called the firmament Hever Shamayim. Remember I told you there were 3 different interpretations of the word Shamayim. In the beginning, God created the heaven, Shamayim. Now that's the universe. He's talking here about the atmosphere, the sky, okay. And the other heaven is what? What's the third heaven? That's the residence of God. So there's 3 different, and you have, in order to translate, in order to interpret it, you have to understand the context. And context right here says, well, that must be the sky. So that's another good example of the context determining the interpretation. There was water in the sky and water below, a dark and damp place, but perfect for what was coming along later. And God said, let the waters under the heaven be gathered unto one place, and let the dry land appear. And it was so. And God called the earth Eretz. Now there's 2 words for earth and land in the Bible, Eretz and Adamah, A-D-A-M-A-H. And we'll talk about those when we talk about the flood, because it's important. Now, we talked about what science says the same thing, right? They said there was land and there was water. There. I got that off that just happened. That's happening right now. In Tonga, at this point, first of all, the Bible said exactly what science says about the formation of land. It's still forming like that. At this point, the earth began to look like the planet that we are familiar with. It had settled down. There was still a lot of volcanic action, but it wasn't being bombarded every minute by huge meteors. Now, that continued to happen, but infrequently. And so we're beginning to get a little look at an earth that's got water on it, it's cooling down, it's settling down a little bit, land's beginning to form. It's being made, it's being fashioned, it's being put together just like God said over there in Isaiah. But it still looks like a cloudy day. And God said, let the earth bring forth grass, the herb yielding seed, and the fruit tree yielding fruit. All right, this is the first mention of life in the Bible. Now, science tells us that several 100 million years, maybe 1 billion years before this, there was life on the planet. Remember our little prokaryote friend? He was the first life on the planet. So why would you think that God would leave that out? You know, that seems pretty important. That seems like something you wouldn't leave out, if it's left out. Now, I'm going to give you a little option in a minute. But what would you think? Well, the only thing I could conclude is that, number one, there was no concept of microscopic life 3,500 years ago. If you had told the average Hebrew herdsman about a prokaryote, he probably would think you'd gone around the corner, as they say in England. Number two, there wasn't a word for it. How could there be? I mean, we didn't know about prokaryotes till a couple hundred years ago. So 3,300 years passed from the time this was written until we actually stumbled on to one of these little guys. So to me, that's the reason. I think that there was neither word nor concept to describe this. And I think had Moses made an issue out of it, or had God made an issue out of it, he would have probably lost his audience. Because up until now, everything they could see. They could see water, they could see land. They have not talked about a single thing in this creation story that they couldn't observe themselves. They could make sense out of it. But when we start talking about microscopic animals, then you got a problem. Now, here's one other little thing. I did some research. The word zera, Z-E-R-A, the herb-yielding seed. Is it up there? Yeah. The herb-yielding seed. If there was a word that described the basic cell of life, that will be it. In fact, it's translated in Genesis 8 as semen, okay? It is the only word that you could possibly connect with a prokaryote, but it is a word that could be connected with a prokaryote, okay? Sperm is not a prokaryote, it's a eukaryotic cell, but it's a single cell. I prefer the other explanation. I prefer the explanation that there was neither word nor concept. Now, the earth was a perfect greenhouse, warm, dark, low light, lots of carbon dioxide. It was well prepared for the first plants, which we're talking about now. And they came along about 700 million years ago. In fact, there are fossils of them that old, so you know they must have been a little older than that. Right after the light, the brilliant blue sky came, the photosynthetic complex plants were able to really thrive. They didn't care as much for the greenhouse as the algae did. They loved the blue sky where they had those big leaves where they could gather up all that sunlight. So you got these little guys, the prokaryotes, eukaryotes, cleaning up the earth. Hard little workers, never get drunk, never get at odds with their wives, always on time, work 24 hours a day, and they don't have to be paid, okay? I mean, gee. By the way, there's still a lot of them around. And they have turned all of these poisons into, not only have they taken the poisons out of the water, they made ore out of them. Wow. They've converted iron, soluble lead, soluble chrome, soluble aluminum, into insoluble materials. Now, insoluble material is one that won't dissolve in water. So they've kind of crystallized out and been covered up with silica and then pressure and iron ore. Thanks to our little friends, our little single cell friends. And by the way, forgot this, oil, gas, and coal. Thank you very much. Same thing. Vegetation falling, and for coal it fell in swamps and places like that, and covered up with land as the land changed, and it went deeper and deeper pressure, bugs, oil, coal, natural gas. Sound like a little plan going on here to me. And the earth pretty much did what God told him to do. It brought forth the grass and the plant life, as he said. And then we finished the third day. Now, here we go. 3 creation days have now passed. The earth was alive with vegetation, but the best was yet to come. This agrees perfectly with science. I've found no conflict so far. And God said, let there be lights in the firmament of heaven to divide the light from day, and let them be for signs and for seasons and for days and for years, and let them be for lights in the firmament of heaven to give light upon the earth. And it was so. Now, some people think the earth and the moon and the stars were created on the fourth creation day. Science says can't happen. And I think science is right. And the reason is, we talked about grass and plants. If we've got a planet floating around out without a sun, just floating out into space, it's going to be so ice cold and so bombarded with radiation that nothing could live. I mean, it's ridiculous to think anything could live on it. Plus, we've already mentioned light earlier on. So what happened here was, you remember the blue sky? This observer that we've been talking about since Genesis chapter 1 looked up, and guess what he saw? He saw the blue sky, and guess what else he saw? He saw the sun, he saw the moon, he saw the stars. I was sitting on a dock at our pond one day, and it had been cloudy for a week and drizzling rain, and I got to thinking, now this must be what it looked like for all those years. We've only been able to see the sun, moon, and stars for 1 billion years. I mean, that's plenty enough, but most of its history it's been covered with a thick cloud that kept anyone on earth from seeing it. Now, it's not a big deal because there wasn't anybody there. But it is a big deal because of the controversy associated with the fact that the creation story supposedly says the moon, stars, and sun were created on the fourth day. They were created on the first day, but they became visible, according to science, on the fourth day. And here's where you can kind of get a glimpse of what I'm talking about. You notice that it didn't say the moon, sun, and stars were created, and God made two great lights, the greater light to rule the day and the lesser light to rule the night. He made the stars also. So the word asa in the Hebrew means to put together something from materials already. Now, had King James's bishops know what we know now, they probably would have said, and God had made, the past perfect tense. He's obviously in the past tense. He said made. God made the moon, the sun, and the stars. The proper interpretation of that is, since we know that they weren't created at the same time at the fourth creation day, a better interpretation would be God had made the moon, the sun, and He had made the stars. And the first time they were visible was on day 4, which makes this absolutely perfectly placed. I mean, if you had written this scripture 5 or 6 verses up, it would have been wrong. I mean, it would have been clearly wrong, because you wouldn't be able to see the earth of the sun, moon, and stars. And does that make sense to everybody? When you think on that a little bit more and think on it a little bit more, it really will make a lot of sense to you. In verse 18 it says, and God set them in the firmament of the heaven to give light upon the earth and to rule over the day and night. Now he just tells us why He did that, why He made the sun, the moon, and the stars to rule over the day, the sun rules over the day, the moon rules over the night, stars give light to the heavens. And the evening and the morning were the fourth day. 4 creation days, the creation of the astrophysical universe. The universe is created, the earth is made, and ready for something more complex than just leafy plants and trees and stuff, which would have existed at the end of the fourth day. Lots of algae in the ocean. By the way, algae is the basis for the whole human food chain almost, or certainly the marine You can see algae blooms from outer space. And algae produces half of the Earth's oxygen. Now, you know, we owe a lot to these little guys, okay? Now, we've gone through Stephen Hawking's version of the creation, the astrophysical creation, because we didn't get into the biology. We're going to get into that in 2 weeks. We've gone through Moses. All right, y'all tell me where you see a conflict. Where is the conflict? Is there a conflict? It took Hawking 191 pages to do it, and it took Moses 800. Well, that includes the rest of the creation too, probably 750 words. But he picked the important stuff. The early earth, dark, formless, changing all the time, scary, vast, fierce, unknown. The water cycle. Before that, even the Tia, the event where we had the first little bit of light come and we cleaned out all of that swaddling band of darkness that he talks about in Job. And then, of course, the water cycle, and the earth was covered with water, which science says that's right. Check that box. Then the land came up. Check that box. Then the first, of course, we talked about why isn't bacteria mentioned in there. A couple of good reasons for that. And then here comes plants. Perfect order. If he'd said, here comes elephants, if Moses said, and God created elephants, then we'd have a problem, right? But we don't have a problem. I mean, he just got it. He just nailed it right down. So, anytime you hear somebody moaning and groaning about all this and saying, well, the Bible is really not a science book, I just showed you that it is. Doesn't this sound to you like something is being prepared? God has just fixed this thing just like He said He would. Do you get that? I mean, that's just not a story from me. I mean, I got that out of the pages of Scripture. I find it to be amazing. I hope you do.